Welcome! In this video, I'll show you how to solve problem 6.6 as it appears in both the second and the third edition of Griffiths Introduction to Quantum Mechanics. Now, this problem states the following. It says, let two good unperturbed states be what we have here, right? So one is psi plus, one is psi minus, and they're alpha plus or minus, psi of A, 0, of course, we are here in the 0th level, plus beta, psi plus or minus, W, B, 0. So of course, A and beta here are determined by equation 6.21, which is what I wrote right here, and equation 6.23, which is analogous to this basically. And then we have equation 6.26, which determines the energy levels, which is what we have already determined. So of course, all of this is based now in the matrix W, right? The so important W matrix that we have already derived. And we will be using it all throughout this problem. So considering this state, right, with of course alpha and beta, our coefficients in the matrix, and psi A 0, psi B 0, two normalized and orthogonal states, right? They are good states, so of course they have to be orthogonal and normalized. And well, the normalization constant is of course in front. So what we want to show is that those psi plus, psi minus are orthogonal. Then we want to show that the expectation value of psi plus, psi minus is 0. And this, of course, in the Hamiltonian, in the perturbed Hamiltonian, some H prime that we don't really need to know because that is the definition of the W matrix or the elements of the W matrix. And then down here, we want to show that if we have the same state, right, here it was different states. Here we have the same state, so we want to find that we get indeed the energies that we expect to find. So, you know, here we are basically going to apply what we have already derived, but, you know, in more general terms. So if we have, you know, just one state with two good unperturbed states, let's see. So the expectation value, psi plus 0, psi minus 0, this is equal to, now we just copy this. So the bra of alpha plus psi A 0, actually, it looks like I'm adding them, so I'm going to do it like this. Alpha plus psi A 0 plus beta plus psi B 0. And now we are taking the inner product. So here we write down the other one. So alpha minus psi A 0 plus beta minus psi B of 0. Okay. So now what we have to do is just use the properties of bras and kets to separate this into several individual brackets. So first of all, we get this term with this. So that is bra of alpha plus psi A 0, alpha minus psi A 0. Then we have this with this. That gives us alpha plus psi A 0 and beta minus psi B 0. Then we got this and this, which gives us, let's see, beta plus psi B 0, alpha minus psi A 0. And then we have one final term, which is with the two betas. So beta plus psi B 0 and beta minus psi B 0. Okay, so now we are, wait, I just realized that I wrote psi, wait, what is this? This is of course simply alpha minus. So alpha minus. Okay, now what we want to do is take out all of our constants. So basically here we have, so we take the alpha plus outside of the bra, so we take it as alpha plus conjugate, right? When we take it out of the bra, it is the conjugate. And then we get alpha minus, which we can simply take out because it is in the ket. And we end up with psi A 0, psi A 0. However, this is 1 because our states are normalized. Then we have here alpha plus conjugate, beta minus, and then we get psi A 0, psi B 0, which is, of course, 0. Then we have beta plus conjugate alpha minus, and psi b0, psi a0, which again, this is 0. And finally, we have beta plus conjugate, beta minus, psi b0, psi b0, which is of course 1. So what we end up with is alpha plus conjugate alpha minus plus beta plus conjugate beta minus. Okay. However, we don't really know, is this 0, is this not 0? It's not really easy to see. So what we have to do now is basically change our alphas for something else. And that is where this equation comes in. So notice that from here we can find beta. Beta is the easiest one to find. So here we have, this is alpha, of course, it doesn't really look like it all that much. From there we can find beta. This is, let's see, we put this to the left, so we get alpha E1 minus alpha WAA divided by, and then we need to divide by this, so by WAB. Okay, so we can of course factor out alpha here. That's gonna make it a bit easier. And there we go. And this of course goes for both plus and minus. So this is for alpha plus minus and for E plus minus, right? This goes for both cases. So let's plug this in. So, well, our alphas will remain the same. We are going to only plug in the beta. So here we get alpha, so beginning with the beta plus conjugate. So if we take the conjugate of this, we get alpha plus conjugate. The energy is real, so nothing changes. WAA is also real. However, WAB, this could be conjugate, so we have to take the conjugate here. Okay, then we have beta minus. So in beta minus, we get alpha minus E, oh, this is, sorry, I put E plus minus, this is of course E plus, that doesn't make sense. Then we have E minus WAA, and then divided by WAB. So notice that we have the product between alpha plus conjugate and alpha minus, which is the same that we have here. So what we can now do is take the factor of alpha plus conjugate, alpha minus out, and we can also take the product of WAB conjugate, WAB. Actually, I'm gonna leave that for one step later. So this is 1 plus, then we have E plus 1 minus WAA times E minus 1 WAA, and all of this divided by, this is the modulus squared of WAB. But we can take common denominator here, and we get WAB squared. Okay, and plus, of course. So we still want to simplify this further. Now, we know the expressions for the energies, right? So that will come from here. And perhaps this will be able to, simplify something. So first of all, we can just take the denominator out, right? There's no need for anything else. So this is WAB conjugate squared. And now let's multiply it through. So this is alpha plus conjugate, alpha minus, modulus of WAB squared. And then we get modulus again. Okay, and now we have these things here. So let's see, we have E plus times E minus. So we get E plus 1, E minus 1. Then we get, and by the way, it's better to multiply first and then plug everything in. Otherwise, the product will be much messier. Then we have E plus 1 times minus WAA. So I guess this will be minus. So E plus plus minus WAA. Then we have let's see, minus WAA E minus 1. So we get minus WAA E minus 1, and finally plus WAA squared. Okay, there we go. So now we can factor out WAA here, right? We have plus, or rather minus WAA, well, let me get rid of that parenthesis, WAA factor of E plus plus E minus, and of course both of them are 1. So what we now need to find is what is the product of our two different energy levels, right? Or basically E plus and E minus, and what is their sum. So let's go to our formula right here. This is the formula that we now need to use. Okay, so I'm gonna take this off to the side so we can work with it. Okay, so what is the sum? E plus 1, E minus 1. Well, let's see. First of all, both of them have this 1/2, so we get 1/2 times. We will get twice this and twice this. So 2WAA plus 2WBB. And then we'll have the positive square root plus the negative square root, which cancel out. So we get WAA plus WBB as our result. Okay, then what is the product? So the product E plus 1, E minus 1. Well, notice that that product is going to give us basically x, we have basically x plus y and x minus y, right? Which is x squared minus y squared, with this thing here being x and this thing here being y. Now, you don't really need to see it like this. You can also just multiply. But noticing that here we have a sum times the difference, right? That means that we get this difference of the squares, which will make our calculation much, much simpler. So we get WAA plus WBB squared minus, and then this square root squared, which gives us WAA minus WBB squared, and then minus our last term, which is 4 times modulus of WAB squared. And of course, all of this is still multiplied by this 1/2, which is now squared, so we get 1/4. Now, let's multiply through. So this first term, so we get 1/4. This is WAA squared plus 2WAA WBB plus WBB squared. Then we have this part where we get minus WAA squared. And then we have the minus 2 times this and this. But there's another minus sign in front, so we get 2 WAA WBB. And finally we get minus WBB squared. And then we have this, so minus 4 modulus of WAB squared. So here we can see that WAAs will cancel out, the WBBs will cancel out, and this with this will add up. So we get 4 WAA WBB, which cancels out with the 1/4. So basically E plus 1, E minus 1, this will be WAA WBB minus the modulus of WAB squared. So there we go. Now we have every result that we needed. So let's plug it into our expression for this inner product between psi plus and psi minus. So what we had before was alpha plus conjugate alpha minus divided by this WAB squared. And then we had this thing here. So this is WAB modulus squared plus, and now the product. The product gave us as a result WAA, so plus WAA WBB minus the modulus of WAB squared. Then we have minus WAA and now times the sum of our energies, which is WAA plus WBB. So this is WAA plus WBB. And finally, we have this WAA squared term. So here we get that this WAA squared will cancel out with this, and this minus WAA WBB will cancel out with this. And finally, the modulus here will cancel out. So this is indeed 0, which is what we meant to prove. So that is part A. Now in part B, we wish to prove this expression. Now I'm going to just quickly move this to the side so we get some extra space. But as you will see, the procedure will not really be very different. So we will simply plug in our expression in here. So psi plus 0, h prime plus psi minus 0. This is, let's see, psi plus is alpha plus psi of A0 plus beta plus psi B0. And then we have our perturbation Hamiltonian, and then we have psi minus, which will be alpha minus psi A0 plus beta minus psi B of 0. Okay, so now just as before, let's separate this inner product into several different inner products, right? This is basically an integral. That's why we can apply linearity. So from the first one, we get alpha plus, so let's see, we get alpha plus psi A0 times the Hamiltonian alpha minus psi A0. Then we get this, this and this. So alpha plus psi A0 Hamiltonian, and then beta minus psi B0. Now let's go for this and this. So that is beta plus psi B of 0, our perturbation Hamiltonian, alpha minus psi A0. And finally, we get the beta, so beta plus psi B of 0, Hamiltonian, beta minus psi B of 0. So with these four terms, now how can we simplify them a little bit? Well, let's take a look at this. So here we can take out our constants as before. So we get alpha plus conjugate alpha minus, and then psi A0, h prime, psi A0. But what is this thing right here? I won't tell you just yet. I will continue to write down the others while you remember that or look that up. It's very important that you recognize it. Now this is psi A0, h prime, psi B0. But what is this thing, right? This is another thing that you should be able to recognize. I'm just going to continue to pull out my constants. So psi B of 0, h prime, psi A0, and then plus beta plus conjugate beta minus psi B0, h prime, and psi B0. Now, what is this thing? Well, this right here is simply WAA. That is the definition of WAA. Similarly, this thing right here is WAB. This thing right here is WBA. And this thing right here, this is WBB. Okay, so now we need to find some way to put everything together and get to something we can actually work with, because here we are a little bit stuck. So just as we did before, we can, right, what we did before is that we also were kind of stuck, but then we substituted basically our either betas or alphas for our expressions of, what they actually are. So the question here is, which one should we use? Well, let's begin by simply substituting our expression that we found. So let's use this expression here for beta plus and beta minus and see how far it will take us. If we end up having problems later on, well, we can always go back and substitute something else. Sometimes, we just have to try a little bit. Okay, so that is what we want to now substitute. So let's see. Now our product psi plus h prime psi minus, this is, so the first part, alpha plus conjugate alpha minus WAA, that remains unchanged. Then we have alpha plus conjugate beta minus, but beta minus is alpha minus, and then E minus 1 minus WAA, and all of this divided by WAB. But we are also multiplying here by WAB. So those two cancel out. Okay, now the next term would be this one. So there we have beta plus alpha minus. But what is beta plus? Beta plus conjugate, of course. There we get, let's put it here. So alpha plus conjugate. And then we have E plus minus 1 minus, also not plus minus, we are in the case plus. So of course it's E plus. Minus WAA divided by, and now WAB conjugate. But what is WAB conjugate? Well, that is simply WAB. Oh, sorry, WBA. And then we have alpha minus and WBA. So again, they cancel out. Whoops, I didn't mean to get rid of that. There we go. Now, we have to go for the last term. So for the beta plus, beta minus, I'm going to write it down here. So beta plus will be alpha plus conjugate E plus 1 minus WAA divided by WAB conjugate. And then we have beta minus, which will be alpha minus E minus WAA divided by WAB. And all of this times WBB. Now, here we will get something quite familiar, right? We can take the A minus to the front, so we get alpha plus alpha minus, and then we have the same product that we had before, which was at E plus 1, E minus 1, and then we had minus WAA factor of E plus E minus, right? And so E plus E minus, and then plus WAA squared. So that is that is what that product is. And we already know what E plus 1, basically what the product and the sum are, right? We found them way back here. So we want to sum these things, basically WAA times this plus this thing. So let's plug it in. Okay, so considering, let's see. Well, let's just write everything down and do as much progress as we can. So we can, as you can see, we can factor out alpha plus, alpha minus from every single term. So here we get WAA. From this, we get E minus 1 minus WAA. From here, we get plus E plus 1 minus WAA. And then we have this thing right there, which is WBB divided by WAB, right, by the modulus of WAB squared. And then we have this product. So let's see what that is. So we have E plus 1, E minus 1, which I already forgot. So that is WAA. So that is WAA, WBB minus the modulus of WAB squared. Okay, so that is the sum. Then we have minus the product. Now comes WAA times that. So we get, whoops, minus WAA squared. So we get minus WAA squared minus WAA WBB plus WAA squared. So from here we can clearly see that WAA, so that cancels out, this cancels out. So all we are left with is this minus the modulus squared. But we are also dividing by the modulus squared, so we are left with minus 1. So basically we just change this plus to a minus. That is the result. Right, so this is minus WBB. Okay, so what now? Notice that we have WAA minus WAA, so we can cancel those two. And then we have E minus E plus, right? We have the sum once again. But what is the sum? The sum is WAA plus WBB. And look at this. This is 0. So there we go. All we had to do was plug everything in and use the definitions that we had learned during the derivation of this method. Now let's go for part C. So in part C, once again, we need to just prove something. So let's take this, let's go to the side and do the same procedure basically, right? Just plug everything in. So this time we will be working with psi plus minus instead of just psi plus, right? This time we have the same levels. Before we had plus and minus, now we have either plus plus or minus minus. But the procedure will be the same. So let's plug everything in. So here we have alpha plus or minus psi A of 0 plus beta plus or minus psi B of 0 times the Hamiltonian, and then alpha, the same thing, right? This time we are dealing with the same state, unlike in the previous cases. So now let's just multiply through. So, and I will take the constants out immediately. So alpha plus or minus conjugate, alpha plus or minus, factor of psi A0, H prime, psi A0. Then we get this term times this. So we get plus alpha conjugate plus minus beta plus or minus, and then psi A of 0, H prime, psi B of 0. Then down here we get psi plus minus conjugate, right, from this term and this term, alpha plus or minus psi B of 0, H prime, psi A of 0. And finally we have beta plus or minus conjugate, beta plus or minus, and then we have psi, no, not like this, so psi B0, H prime, psi B0. Now notice what we have. This again is WAA. That's why it's so important that you feel very confident not only using the W matrix, but also understanding its components. This thing is WAB. So this is the same as in the previous case. That's why I'm going quite fast. This is WBA. And this thing is WBB. Okay, now notice there is something else. We have alpha plus conjugate alpha plus, or alpha minus conjugate alpha minus. So this thing right here is the modulus of alpha plus minus squared. And the same thing here with the beta. This is modulus of beta, both for the plus and the minus case, squared. However, here we don't have that. So for that reason, let's write either beta or alpha in terms of the other, just as we have done before. But notice this time, because we know that if I write beta, I will get alpha plus minus, right? The formula for beta, let's look at it again, it's right here. If I plug in beta, I get this alpha plus. So I will get, after putting this in, I will get alpha plus conjugate alpha plus and the same for alpha minus, of course. So I will get the modulus of alpha squared, which is very good. But if I plug it in here, do we get the same? Let's see, we would get, perhaps we could try. So let's see, let's try plugging that in into both expressions. So the first term is, of course, the same, WAA plus, and then we have alpha plus or minus conjugate, and then we have alpha plus minus, and then we have E plus or minus 1 minus WAA, and all of this divided by WAB. But we are also multiplying by WAB, so that part will simply just go away. So we are left with alpha plus minus, just as we wanted. So this thing here is the modulus of alpha plus or minus squared, times, of course, this thing, which is, I'm going to write a little bit neater here. So E plus minus 1 minus WAA. Now we have this. So then we have, now let's plug in beta conjugate. So beta conjugate, this is alpha plus or minus conjugate. And then we multiply by E plus or minus 1 minus WAA. And then we divide by WAB conjugate, which is the same as WBA. And here we have to multiply by WBA. So just as before, these things cancel out, this with this. And I almost forgot to add this part, right? This alpha plus or minus. So we do end up with alpha plus or minus modulus squared. So let's just write it here. So this is alpha plus or minus modulus squared. And notice, however, that we have arrived at an impasse here. This is correct, but our last term is beta plus or minus squared WBB. So we get alpha plus minus squared WAA. We have quite a few things, because alpha plus or minus WAA, we will get that it cancels out here. And so let me show you. So this part cancels out with this. So we get alpha plus or minus squared E plus or minus 1. And then here, however, nothing cancels out. That is the problem. We can't do anything with this, right? So this makes me think that perhaps we shouldn't have plugged in the formula for beta, but rather the equivalent formula for alpha, right? So this is something that happens sometimes when you're solving these problems. Actually, I don't need to delete everything. Right, this is something that happens, don't worry. So what we will now use is the equivalent formula, but for beta. Now let me show you. It is right here. So we know that, similar to before, alpha WBA plus beta WBB is equal to beta E1. This is, of course, valid for both the plus and the minus cases. So this is alpha plus minus, beta plus minus, beta plus minus, E plus minus. So from here, we can easily find what alpha is in terms of beta. So alpha is E plus or minus 1 minus WBB times beta plus or minus. And all of this is divided by WBA. So this is what we will now plug in here. So that is why we had to be, a bit careful, but it's nothing too bad. So beta plus or minus conjugate. Now I write the alpha that we just found. So alpha, this is going to be beta plus or minus factor of E plus or minus 1 minus WBB divided by WBA. And all of this is divided by WBA. So look at this, this cancels out quite easily, and we get modulus of beta plus or minus squared here. And finally, we add this part, which is plus modulus of beta squared. So now notice what's going on. So we have that this expression, psi plus minus h bar prime, h prime, sorry. This thing, this part cancels out with this cancels out with this. So we have left alpha plus minus squared times e plus minus 1 plus beta plus or minus squared times e plus minus 1. So we can factor out e plus minus 1, which gives us the modulus of alpha plus squared plus beta plus or minus squared. But this is 1, right? Because this is the probability of finding the particle in state 1, probability of finding the particle in state B. If you take both of them, you get 1 because it's the only two probabilities. And then we have, right, that this is simply the energy. And there we go. We have now proven the final step. And as you can see, all we had to do was simply use the definitions of betas and W's and just understand very well what each thing means. Again, if there's any doubts, it is good that you check out the procedure where we derived the W matrix, just because of how important it is. So that's everything for this video. I hope this was useful to you. If it was, please consider leaving a like on the video, commenting and subscribing. And if this really helped you, maybe consider supporting me on my Patreon. So I'll see you in the next video. Thank you very much for watching.